All right, so we're going to talk about vertical asymptotes, horizontal asymptotes, and symmetry. And the symmetry we're going to talk about refers to functions that are odd and functions that are even. So, real quick, a vertical asymptote is an x value that causes the denominator of a rational function to equal 0. So we have x's in the denominator, we're going to find where there's 0. One thing to be careful of is if it's a value that makes both the numerator and the denominator 0, it's not an asymptote. That would be a hole. It's called a hole, and literally you put a hole at that x value. But I don't think there are any like that in your homework. I kind of double check that. A horizontal asymptote is the y value of a function as x approaches infinity and negative infinity. Sometimes we call it the end behavior of the function. And it's actually pretty easy to figure out. Again, we'll look at some examples. All right. As far as symmetry goes, an even function is a function that is symmetric over the y-axis. So the left-hand side and the right-hand side are exactly the same. And the way we can tell is if I take a value and plug it into the function, I get the same answer that I would get if I take the opposite of that value. And they're using x and negative x, but you could use just a number and it would work. A number and its opposite. An odd function is a function that is symmetric around the origin. And for that one, if I plug in the opposite of a value, I get the opposite y value. So for instance, x cubed is odd. If I plug in -2, I get -8. If I plug in +2, I get +8. So the opposite x value gives me the opposite y value. It's great. It's awesome stuff. All right. So we're going to do a couple of examples. And I did this on a separate page so that I don't have to keep scrolling up and down. We're going to determine if there are any vertical asymptotes. Excuse me. If there are any vertical asymptotes, horizontal asymptotes, if the function is either odd or even, and then we're going to find the x and y intercepts. And then finally use that information to sketch a graph. Oh, excuse me. So what I'm going to do is go to a split screen. There we go. Just a little behind. So that I can tell, okay, this is stuff that I want to find. So for vertical asymptotes, that would be where the denominator is 0. So I want to find the value for x that makes x plus 3 equals 0. And that would be? What value for x would I plug in to get 0?
0.
-3 would make my denominator 0. So I'm going to have a vertical asymptote, a vertical line right there. And I actually draw those in, and when we get to the graph, I'll show you. But I draw those in as kind of a dashed vertical line. Part B asks about the horizontal asymptote. And when we have a rational function, what I can do is take the largest power of x in the numerator and the denominator. So in this case, my largest power of x is just x in both. And what is x over x? X divided, something divided by itself. So I'm going to have a horizontal asymptote at y equals 1. I should actually so what this is saying, as x gets larger and larger, basically adding 1 or adding 3 doesn't affect my total a whole lot. I'm going to get really close to that value of 1. I may not ever reach it, but I'm going to be so close, you're going to need like a microscope to see the difference between the value and 1. All right, then what else did we want? We wanted symmetry. Determine whether it has odd or even symmetry. All right, so do that right here. And so what we can do is pick a number. So I'm just going to pick, and I'm not going to pick -3. All right, so I'm going to pick maybe -4. So I'm going to check f of -4, and I'm going to check f of +4. Now, if it's even, I should get the exact same value. If it's odd, I should get opposite values. So let's see, -4 plus 1 over -4 plus 3. So -3 over -1, that's +3. And down here, 4 plus 1, 4 plus 3 would be 5 over 7. So are my answers exactly the same? Are they exactly opposite? What's that?
The 3 is opposite.
Okay. The 3 is opposite of what?
The 3 is opposite of
Okay, but I'm just looking at the answer. So I'm just comparing the 3 and the 5/7. Yeah, so they're not opposites. That means that it's not going to be symmetric about the y-axis or about the origin. So not odd or even. Part D, find the x-intercepts and the y-intercept. So for the x-intercept, we would take x plus 1 over x plus 3 and set it equal to 0 and solve. So to solve this, what I would do is multiplied by that x plus 3 that's in the denominator. And the reason I'm going to do that is on the left-hand side, they cancel out. It just leaves me with x plus 1. And what is x plus 3 times 0? 0. And then subtracting 1 from both sides, I get an x-intercept of -1, 0. For my y-intercept, I just plug 0 in for x. Now this is the tough one, right? Oh, 0 plus 1 and 0 plus 3. Okay, good, 1/3. So my y-intercept is 0, 1/3. And now I want to graph. So I'm going to pull out a piece of graph paper and go back to that dual page display because that's going to help. So for my asymptotes, I'm going to draw some dotted lines. So I have an asymptote at -3, and I have an asymptote at positive. We said it wasn't either odd or even, so that's okay. We said at -1 we get 0, and at 0 we get 1/3. I'm going to go back to this. What's that? Yeah? Oh, all right. Silly computer. All right. So this didn't turn out so well. Let me try this again. It's 1/3. And so what I know is as I move toward that asymptote, I'm gonna come close to that value. So this is gonna go like this. And this way, as I move toward this asymptote, I can't cross the asymptote. So I just have to continue to go down and kind of hug it. And so I probably want to try to find a couple other values. On the left-hand side of that vertical asymptote. So I'm going to check a couple of values. Like maybe -4 and -5. So I'm just going to plug in -4. I get -3 over -1, which is 3. And then I'll check -5. -4 over -2, which is +2. And so the same thing, I know I'm going to approach this asymptote and approach that asymptote. With something that looks like that. So if you have a vertical asymptote and your x and y intercepts are on the same side, you're probably going to need to pick just a couple of values on the other side of that asymptote to finish off the graph. So what I did, I mean, there were like 40 questions in the homework. I chose just to say, hey, do the ones in this first column. So it's hard to write them out other than it's every fourth problem.
Can I just take a picture of that?
Yeah. One thing so I did want to talk about this one a little bit. If it goes, there we go. With the asymptotes. So in this case, if you think about the largest power of x in the numerator and the denominator, well, there's a factor. I mean, I can reduce that to 1 over x. And what happens as x gets larger and larger, this goes to 0. So think about x being 1,000,000 and then 1,000,000,000 and then 1,000,000,000,000. And every time I get a larger value for x, my fraction becomes smaller and smaller. So that would be a vertical asymptote of 0. It's really the only thing I wanted to show on that one. Okay? And again, if you want graph paper, I gave you enough yesterday, right? You're okay?
Yeah.
Excellent.